Yeah, but imagine they'll say usually changes something.
Yeah.
So that's probably why.
If you're getting like 40, you should be good. That's what I'm getting when I think it's pretty decent at getting like 7.
Yeah.
Seriously. Quest was 7, that's like 7.
Yeah, Quest.
Usually
They have a tendency to overload
I usually just put a 1
their
by that.
systems and then that slows down really bad.
Like usually
Putting in new
surgery
surgery,
should
there's
be
so
like
many more people in there. And if everyone gets on that shit.
This bottleneck is so bad.
Same thing.
yeah, derivatives they'll usually like
My
have
neighborhood, I'm pretty.
prime effects. So you just put it at a 1, like an exponent.
Yeah, network. Just for much. Trying to see servers.
Like 5 minutes of trying to squiggly notebook the thing.
An iPhone or something won't kick it down. You do that, it'll stay one channel and it will take the other.
That's what I was liking about the edge. Just try out just about the interference so much. Well, I think there was somebody saying running on the energy sometimes that it slows down the changing track force.
It's not true. It just says what it will do is it will come down and slow it down. So when you're in your house, someone has a key card or anything.
Okay, let me know. Has everybody else gotten into Moodle yet? Has anybody not gotten into Moodle? Other than you? Everybody's okay with Moodle access?
Yeah.
Good. Okay, they're pretty good about it, so if it's not working, shout louder, and they seem to be responsive. All right, let me go through this really quickly because we're going to form teams in a few minutes, so I want to know who's here and who's not here. So Brendan?
Yeah.
Calvin?
Here.
David?
Here.
Lev?
Here.
Dimitri?
Here.
Alexander?
Here.
Colton?
Here.
Dima? Ryan Bergquist and Ryan Foreman.
Here.
You're both Ryan J. So I have to go to last names. Austin.
Here.
Matthew. Solius.
Here.
John. LaRosa. And then Rebecca. Joshua. Lucas. Kyle. Jason.
Here.
Kerbin.
Yeah.
Christopher.
Good guy.
All right, cool.
Good big thing. No, I left those two.
All right, I have 21 people in here. I have 2 who haven't shown up yet in 3 classes so far. So the person who just walked in, talk to me after class. You can go ahead and add in this section. Okay. So Moodle, I made some changes to it. I posted the open lab hours in that reference section in the very top. I also posted an errata sheet for the textbook right after the textbook link, so the other person and I, when we find mistakes in the textbook, we're just sort of updating that list. So if you find any mistakes or typos or errors that aren't in there, that's where they go. Most of those mistakes are cosmetic. There were a few that like you couldn't do the problem because it was wrong. I'm posting the lecture slides. I'm uploading the video from yesterday right now, and I'll start uploading those. But they're really boring because I can't get myself and that screen in the field, even on a high def. So you get to stare at a never-changing screen up there and hear this voice off on the side. It's not very exciting. So I might just rip out the MP3 and post those or something. But anyway, I'll start putting those up, and at least the audio will be available. Any questions or comments from yesterday or Monday? Okay. So let me talk a little bit more about lab number 1. There you are. Have you gotten into Moodle yet? Have you gotten logged on to Moodle yet?
Yeah.
Okay, cool. So lab number 1, you can find it off the syllabus, or you can find it through the Moodle page. But basically, lab 1 is about robotics. Okay, we're going to be using those Lego Mindstorm kits. And I was going to show you a basic introduction to the tools, just the kinds of things you can do and how the programming model works. It's a graphical language, drag and drop. But I can't get Windows on here to show it properly on the display size that I have here or there. I seem to need a larger screen for some reason. So that's not going to work. But if you haven't used this before, or you haven't tried it yet, or you aren't confident just jumping into it, I'm going to be in the lab this afternoon from 4 to 7, and I'm happy to give you a quick introduction, or if you want to come to work on it and you have any questions, I'll be here for that. Or any of the other open lab hours. Anybody who's in here should be familiar with the kits, I believe. But basically, they're Legos. They're different Legos from when I was a kid. When I was a kid, Legos were just those little blocks with 4 or 6 or 8 pegs on top. And now Legos are, I mean, they're pins and they're what? Yeah, they're pins and linkages and gears and pulleys and all kinds of things. And that's not just Mindstorm. Apparently, that's standard Lego now. I had to talk to some 8-year-olds to find this out. But you can build machines with them. And so there's this mechanical aspect where you're sort of putting things together, and this was just one I cobbled together on my own. Which I can't really demonstrate to you because I can't make the software run. But it's just it's a simple little robot. It has 2 motors, so in your kits you'll see these servo motors. You'll have 3 of those, so the front wheels on each side drives, and there's belts that you can use to connect to the back. This one I'm trying to build it so that it will actually compute prime numbers using an old technique called a sieve. So it's going to move around. It's got an optical scanner to detect a grid, and then it's going to use a pen to put X's through the numbers that are not prime. And after making a few sweeps, you should be left with a chart of all the prime numbers up to some range. Anyway, so you have this mechanical component that you put together and build, and then there's this brick that sits on top that's got like a 32-bit ARM processor in it, really nice setup, a bunch of memory. It's got flash memory, so it'll remember programs that you download. And you can take the motors, or the main actuators, and you can hook those up to any of 3 different outputs. And the programs that you have in here can drive those motors. They can sense the position of the motors and so on. And then you have 4 sensor inputs, and this is a color sensor. There's touch sensors, there's an ultrasonic sensor, and there's a lot more back there that aren't standard. And you can plug those in here, and you can write programs that will, you know, look if there's an obstacle within 6 inches, and if there is, back up, turn left 30 degrees, and go forward, and things like that. It's a really fun environment to work with, and it's a pretty simple learning curve. And once you get through the learning curve, it's just ridiculously fun because you can do all these pretty powerful calculations and operations. The software that comes with it is on a CD that'll be in the kits there. And it's also installed on the workstations back here. And if you want to work with this graphical interface, that's fine. Like I say, it's drag and drop. You drag a motor over here and you tell it I want to go forward for 3 seconds. And then you drag a conditional block and you tell it I want something to happen based on the state of the light sensor. And you tell it what the threshold is and so on.
How closely does it match the LabVIEW environment?
I'm not familiar with LabVIEW other than through this, so it may be very close actually. Because I mean, it was developed from LabVIEW as far as I understand. I've heard reports that some of the software is a little buggy. I haven't had any problems with it, but I haven't used it much. If you're comfortable with or interested in sort of a more traditional programming language, there's other things. There's one called NXC, not exactly C. It's a standard programming language that you can use to develop programs for this brick, and it's much more powerful. It has the full gamut of scientific functions. You can do trigonometric functions and complex conditionals and all kinds of things. So if you want to get very sophisticated on the control, you can go to this procedural language, NXC or NBC, next byte code. But the drag and drop interface is really powerful. And like I say, it's a fun way to just kind of like start off and get something moving around like within 5 or 10 minutes. So come in and start playing with that. If you're stuck, talk to whoever's in the open lab and get some ideas and just sort of dive in. Is the best way to learn how to use this thing. So for the lab itself, there's basically three things you're trying to do. You're trying to study team formation, okay, and how to work in a team. We'll be talking about those things next week, along with communication skills. And you're working on creative problem solving, which we'll be talking about week 3. Okay, so this is sort of a hands-on way to explore these ideas that we're going to be talking about over the next 2 weeks. Go through the lab and read the procedure. I'm not going to go through all this right now, but basically there's going to be this competition about a month from now on that circular table where you have 2 robots and you start them 90 degrees apart, and the object is to push the other one off. And they battle for 2 minutes until someone falls off. If you're both on the table after 2 minutes, the one that's closest to the center wins. And I'll set up some sort of ordered seeding of competitions, so there'll be multiple competitions, and between competitions you can go and revise your programming or your hardware design or both based on what happened. We're going to work in groups of 4, probably 5 if we actually have more than 20 people in here. There'll be some groups with 5, that's fine. And then you have 2 things that you're going to have to turn in for that. Okay, there's going to be a general report, and you can find write-ups on how you're supposed to turn this in, what the format of the report should be. But basically, you're going to talk about your experiences in putting the team together and using the things you've discussed to do your problem solving. You're going to describe the results that you got from doing this, and then discuss how the robot actually performed in competition compared to what you had expected it to do and what changes you might make. So that's your basic report. And then you're also going to do a peer evaluation. And you're going to do an evaluation of how well your team worked together. What stage do you think your team is at? We're going to talk about 4 stages of team formation: forming, storming, norming, and performing. So you're going to assess your team and decide where you were in those development stages, and also assess each teammate's performance, how they contributed to the project overall. So you'll be doing 3 pieces to this lab. The first piece is the actual competition, and then I think about a week later, those 2 reports will be due: the basic report on the team and the peer evaluation report. Okay, so I want to take a few minutes and go ahead and put yourselves together in teams of 4 people per team, and 4 or 5. Okay, we don't want any teams with fewer than 4, but there's going to be some overflow. If you don't know someone, pick someone at random. We don't all form the person who's won this competition.
Sure.
Right.
All right.
Hi, people. You guys don't have a good person. Am I doing?
Sure. We need another person. Right here. They've got a team of 5, so let's see where you can
I like a super bomb that can have like turns into a helicopter and picks you up, and takes you off the car.
Of course.
No, because then he'd be out the table.
I can make it
Yeah, it breaks into
Thursday, Friday morning.
Theirs breaks into 4 different things. Parts of it go on. Too pushing, too pull.
It's actually it's a really simple strategy to
I'm going to try to finish tonight.
Imagine the same person.
actually took this part of that before surgery.
John.
Mid chances fly a few times. It's got to be big and heavy.
Nice to meet you.
Yeah, that's what I figured.
It's making us big and heavy.
Yeah, big and heavy.
Yeah, we made like a small type one. It's like a big ball.
Yeah, I'm Ian.
Nowadays, it's fast and light.
Yeah. Nowadays, it's competition. That wasn't a thing about it.
Robotic competition. You think fast and light.
Yeah, okay. Sure.
Super robot competition.
It's controversial. Wait, we need a team. Team name? Team name?
I don't know what
And your name? Yeah, Russians and obsidian.
Especially around Portland.
Sure, Portland, that area.
Okay, and as your team starts to come together, if you've settled on the 4 or 5 people who are going to work together, one of you go back and grab one of those 5 tubs of parts.
we've got kit numbers.
It really doesn't matter to me.
So, we all have these things.
I won the,
Yours one to one. Alright.
I took it back to summer closure, but had to withdraw. I'm taking it.
I was sticking the spring that I was but we used the other one.
First generation.
Just keep ranking.
Not
These are okay.
Yeah.
yeah, I know. They're
So inside your kit should be a checklist. So there's a lot of parts in here, but these are really expensive ones. You want to make sure that these are actually in there. Roller brick, which is like half the price of the kit. About 300. That's from the Lego. There's an older version, but it seems to actually be more.
Those are all the motors.
I need to see what that looks
color
like.
sensor.
Like their sound sensor, color sensors.
Yeah, the brick's like $150 by itself. It's got really good stuff in there. Oh, really? Yeah.
Yeah, so just like it like lets off light that makes it
Yeah, it's so pretty far.
or not, it makes it like drive off the sound.
So I'm assuming they're all there.
Here's something that like makes it drive off the
In
edge.
case turns out the touch sensor has a small button in the front. You press. There's 2 of those. The ultrasonic sensor, transmitter, and the receiver. Color sensor is
Maybe we can find something. Can you write your info down? I'll email you mine here tonight. Make it launch.
Maybe this is for when
Yeah. We give it back or what?
Hey Nick, we need your
Or is that when we give it back?
the sheet should be initial.
Yeah, it is.
Yeah.
But it says pressure. Pressure initials down the
Yeah, so, oh, okay.
Is that what we return?
Thanks for one we return. Just to say that.
Interactive turbo mode.
It's a big piece of cardboard.
I thought it was like
It's got a pattern on it. And the last thing I need you to do, once you're satisfied, you go, come in here, put your name down, on this list, and put your number you have for the kid. So your kid will work.
Yeah, in the book they give you like basic layouts, and actually tells you how to build one of them, shows you where to put all the pieces.
I think for most part, we're supposed to come up with something vaguely based on. Or just that all.
Yeah, it's basically like old school Lego books.
when you say the sheet, I think it's probably like
Design and the simplest program. You just went forward and until the light sensors told you to go backwards, and went backwards 5 seconds, and then forward again. It didn't turn anything. Yeah.
Was it big?
No,
I got bored with that map.
It was with black
but
dogs.
we went out there to get
Always had like that one basically just made a huge robot. Like they just packed everything on. It went straight to the center, stopped, and they would basically fix the time it's fine. And then we went right
That's not, that's great. As long as you can make it so that it's not easily moved.
well, that's why you pack it all on.
Yeah. I mean,
They don't get enough. They don't get that much momentum. So I mean, as long as you have the biggest one.
Well, I mean, if yours isn't a lot bigger than the other ones.
It's pretty hard to move them, especially if you have like.
Yeah, I was gonna say, as long as they're tractioning on whatever surface it is.
basically what we did, we just built everything, we built our design, and we just started adding pieces in different ways.
I was thinking about that yesterday.
On the very bottom.
I'm gonna pass these around when it gets to you. Just put your name down next to whichever in there. And if you're Ryan, give me a last name.
We can get like wooden plates you can stick straight to it.
So, when do you guys want to meet up to?
We can.
To start?
I think we have
What are you?
stick them right in the middle. We can.
An 8 to 9 class, so I can't make the first.
Well, I have classes at that time too. I wouldn't be here at 8 anyway.
I have class from 11 obviously not Monday. Friday. I'm free then. That's like there was a 9 o'clock hour because I was like, I can't make it. Most of the time. Well, also it's during the day.
Are we gonna have like set goals for who's going to what?
Alright, so let's take one more minute and
This, you can have more people like we can think of a good idea and have input, but for the most part, it's going to be like just build the, you know, like it's not like a huge machine. You can't have it with like a couple of all there. So basically, as long as we all agree on an idea, the actual building is not going to be the difficult part at all. What day do you get?
Monday, Friday, we're but if I choose, it's not good because it's my birthday. I'm not here in the morning.
Thursday is the business day. Like it is.
What do you want to do? Tuesday?
For all the guys I know that work,
Either of you have preferences on when we go?
Basically, here every day.
Did you guys find there? But
Like,
I don't know if that actually sounds.
Yeah.
Alright, so I'm going to go ahead and get back to the lecture now. We're going to talk about ethics. The other thing, come up with a name for your team. Okay, we're not going to have a team 4 and team 5 and team 6. We got to have a name. So take some time, figure out a name, and then when you decide what your team name is, you can add it to the first list. Just pop there on the left. Alright, so today's lecture we're going to talk about ethics in engineering. And a good place to start is, what's the definition of ethics? What do we think of when we use the term ethics? Perhaps particularly applied to engineering, but in general. What sorts of things come to mind? Any ideas? Safety. Important is. What else? Is that all we have to do to be ethical? Don't lie, cheat, steal, and be safe.
Kind of follow a set of rules or standards.
Okay.
Just kind of summarize.
Definitely rules and standards.
Confidentiality.
Confidentiality, that's a big one. Could be. You could probably lump everything under rules and standards, but you could also be ethical without having any formal rules and standards. So it's maybe a more specific example of rules and standards.
About traceability, as far as your documentation, materials used.
Okay. Traceability, maybe accountability. So being accountable for what you do. That's good.
Competence?
Competence, definitely. When I type this on my computer, I get a little squiggly line when I misspell something. I can usually guess it right the second time. I don't have that here, so forgive my spelling. Anything else?
I guess something about how it would affect the people that, how it would affect the people that you're, or things that you're affecting, I guess.
Okay.
I don't know
So,
what it's called.
yeah, how about consideration of consequences?
Sportsmanship?
Sportsmanship, good one. We'll talk about that in more detail. Okay, there is a sense of fairness in the things that you do if you're behaving ethically. Okay, so this is a pretty good list. So the definition from the book, which is from dictionary.com, rules and standards covering the conduct of a person or members of a profession, principles of right conduct, theory, or system of moral values. So this is much more detailed. I like this. When we talk about ethics, we can talk about stakeholders. Okay, stakeholders are basically individuals or groups that are in a position to affect the outcome of some action, okay, to impact its success or failure. And they're also the individuals or groups who are most impacted by the success or failure of an undertaking. Okay, so this comes into some of this consideration of consequences. I think one of the big problems comes when those two groups are different from each other. When you have one group that's in a position where they can cause a huge impact, and you have a totally different group that's affected by that impact. Okay, this is what happens when an engineering company decides they want to dam a river to create a hydroelectric plant, and the government is in favor of it, and the people who are living in that valley, their land is going to be underwater when this project is done. Okay, that's a case where you have stakeholders that have different interests in this project, and it becomes an ethical problem. The engineering part of that is part of the challenge, but how do you deal with this difference in what the stakeholders want? That's a big problem, and that usually happens. It's the one with the power and the money that wins out, unfortunately. But there are exceptions also. So typically, stakeholders in these endeavors are yourself, the person you're working for, the general public, the client that you're doing work for, or the people who are going to use the system in the end. Those are typical stakeholders to keep in mind. And when you're assessing a situation from an ethical point of view, you can think of it in terms of the impact by or on the different stakeholders. Okay. So National Society of Professional Engineers, NPSE, has this code of ethics that they've developed, and you can find the full text of this in your textbook. You can also find it online if you just Google NPSE and ethics. This is all available. Basically, there's 7 what you call canons, 7 fundamental principles, and I believe these are ordered. Okay, the order is significant. They go from most important, I won't say least important, but the precedence is given to the ones higher up. Okay, so number 1 concern, safety, health, and welfare of the public. Okay, so, and that's the first one we got here, which is nice. So that's number 1 concern. Okay, safety, general welfare. Performing service only in areas of their competence. So we got that. If you're not a structural engineer, don't do structural engineering. Okay, you took a structural engineering class 20 years ago in college. Yeah, I kind of remember the basic ideas. Yeah, I don't think you have to worry about that crack in your basement. Okay, if you're an engineer, you got to think carefully about how you're going to use that knowledge. Okay, and what credibility people are going to give you because they know you've got a master's degree in engineering. Well, if it's something that's affecting somebody's well-being or their livelihood or their life, don't go outside your competence area unless you're very careful how you do it. Okay, now if you tell someone, I don't work in this area, but I think you should talk to a specialist, right? That's fine. So, performing services only in your area of competence. Issuing public statements only in an objective and truthful manner. Okay, so lying, cheating, a little lump stealing in there too. And that also starts to get into sportsmanship. Okay, so if you're an engineer, if you've got lots of letters before or after your name, you have credibility, you have clout. Okay, and how you use that is an important consideration. People will listen to you. And if you have an opinion about something, and you state that opinion without saying this is just my opinion, people are going to take it as being scientifically engineering sound. Okay, so you have this obligation to, when you're speaking to the public, make sure that you're speaking factually, not just from opinion, okay, and truthfully, not deliberately. Acting for each employer as a faithful agent or trustee, so confidentiality. When you work for someone, making sure that you understand what your obligations are to them as their employee and as they being your employer. Avoiding deceptive acts, lying, cheating, stealing, and conducting yourself honorably, responsibly, etc., so as to bring about honor to the reputation of the profession, because you're a representative of the profession of engineering. Okay, and what you do sort of speaks to the whole field and speaks about everybody in that field, at least in the public's eye. Okay, and so sort of keeping that in mind. So those are the 6 basic canons of this code of ethics. And in the textbook, they talk about the rules of practice, and those are basically more detailed on each of those 6 canons that give you specific examples and more information about what those sentences mean. But you can read those on your own. And then there's a set of, I think, 9 professional obligations that they list. Basically, given those canons, how are you supposed to act? What are you required to do or not do? So, highest standards of honesty and integrity, strive to serve the public interest, avoid conduct that deceives the public. Okay, these are all just restatements of those initial canons, but this is sort of how you put them into practice. Confidentiality, don't disclose it when you're not supposed to. Avoid conflicting interests. In the government, it was stressed to us that not only did you have to avoid a conflict of interest, you had to avoid an appearance of a conflict of interest. And that was considered almost as bad because it goes back to the public's faith in the institution. And even if you're not doing anything wrong, if it looks like you're doing something wrong, that's considered something that you need to avoid. Okay, you need to somehow prevent that appearance of a conflict. And I think that's mentioned in here also in the textbook. Untruthfully criticizing other engineers or improper or questionable methods. Okay, again, using your position to basically harm somebody else in the field for your own personal gain. Okay, sportsmanship. And then accountability. Okay, accepting responsibility for your actions. There's traceability and accountability. And all of these things are rules and standards. And giving credit when credit's due. Okay, which goes along with accepting personal responsibility. Okay, so you do something wrong, you admit it. Somebody else does something right, you admit that. Okay, so it's about integrity. And in the text, again, they flesh all of these out in a lot more detail, but those are the basic 9 obligations that they listed. And that's good. We got a really good coverage here. We hit all the main points. I don't think we missed any. So you can read that. I recommend that you go through it in the book. It's 3 or 4 pages long, but it's good to have read through at least once, just so that you're familiar with it. And when something comes up, it might trigger your memory. All right, so some examples. You're doing work at your job and you have an ethical concern about something that you've been asked to do. And you tell your boss what your concern is, and your boss says, don't worry about it. I'll accept personal responsibility if there's a problem with this. Okay? What's your feeling about that? Blackmail your boss, you mean?
No,
Other way around. Okay. What else?
still your personal responsibility.
It's still your personal responsibility. People generally agree with that. I mean, your boss can't really absolve you of your responsibility to look out for the public welfare. Okay, even if they think they can. Okay, because your code of ethics is not about your boss. It's about these things that we're discussing, these 6 canons of proper behavior. So that doesn't really get you off the hook. About the same situation, your boss tells you, listen, there's circumstances here that you don't know about and that you don't understand. And it's not your job, okay? You need to do the engineering. I need to worry about the consequences of it. So do your job. Okay, these things don't just pop up in TV. They actually do happen sometimes. And I think, again, we can kind of agree that that's not really a valid excuse. Okay, if anything, it would make me kind of suspicious. Apparently there is something going on here.
What are those things that you're not all aware of? You have a massive amount of money you're making?
Right. Okay, so how about this one? You sign a non-disclosure agreement to do some consulting for a company. After you sign the agreement, they show you their product and give you the specifications on it, and you start looking at it. And while you're looking at it, you discover something that you think causes a safety problem. You realize if people actually use this thing, once it's released, people are going to get hurt. and you go back to them and they say, we don't want you to assess the safety, we want you to improve this piece of the system. And you say, well, there's a safety concern, and they terminate your contract. And they remind you on the way out the door that you're still under this non-disclosure agreement, that it was binding even after the contract ends. So what do you do there?
Look out for the public safety.
You look out for the public safety, but you also have this confidentiality agreement.
Well, according to the list, safety was
Right.
above confidentiality.
Right,
So I
so
assume that.
that's why the
trumps
ordering
it.
is important. But it is an ethical dilemma. Like two things that are kind of,
Does it ask a lawyer?
Yeah, so I thought about this yesterday when I was writing somewhere, and I think for me, I would find an impartial but wise friend, someone I could trust, and who I could talk to without disclosing specific information, and I would bounce it off them and see if, I'm overreacting, or see if it's a no-brainer, like you need to take out your cell phone and make a call right now. Get a sense from somebody else just to make sure that I'm not too wrapped up in it. And then if it's a serious problem, I would probably find who I needed to talk to, possibly through a lawyer, depending on the scope of it. And this can be a problem when the company that you're dealing with is someone like a government. Okay, and this does happen. How many people here know about Challenger disaster? I'm guessing most of you don't actually remember it when it happened. It was one of the saddest days I can remember, but it kind of changed the world forever. NASA was just a different entity before that moment. But that was a case where, so the shuttle went up, and a few minutes after it launched, it exploded. And it exploded because the O-rings that seal the fuel tanks had gotten cold enough that the seal was no longer fully functional, and fuel leaked out, and it ignited, and the whole thing blew up. And that was a known possibility. Okay, Thiokol, the company that made these solid rocket boosters, they knew about this problem with O-rings when they got below a certain temperature. They spec'd them down to like 40 degrees, and they were launching, it was 18 degrees. Okay, so it was below where it was supposed to be. This had happened before, apparently. And it was one of these things where the engineers said, this isn't really safe, there's a problem here, but the whole world was watching these launches. There was a school teacher going up on this one, and so a lot of people were watching it, and a lot of hype, and there was a lot of pressure to go ahead with this. This hadn't been a problem before, and some of these engineers were in an ethical dilemma. How much noise do you make? How far do you go in trying to do what you think is the right thing? Particularly when people who supposedly know more than you are saying it's not a problem. The investigations that came after that accident caused a lot of changes in NASA and elsewhere. It was a really powerful case study in ethics. In Canada, it's mandatory reading in ethics programs now. Because these aren't always cut and dry situations. Okay, sometimes they are challenging. It's the easy ones that the obvious ones that are easy, but sometimes it's a bit of a quandary. Okay, this one is pretty straightforward because we generally know that safety is coming before confidentiality. Sometimes you can just avoid situations up front. So when I was about 20 years old, I interviewed for a job somewhere. I was switching jobs, and I got into the interview, and the guy came at me with attitude. First of all, he had my resume in his hand, and he was like, I'm looking at this resume and all these things you have here, and I see you, and you're this young guy, and I'm thinking, there's no way you actually have experience with all this stuff. You're just putting words down here to impress me, but how much experience could you actually have in all of these? Okay, not a good way to start a relationship with someone. So I came back with some attitude, and I started telling him some of the things I'd done specifically in these areas, and he was like, okay, I was wrong, So that had set off a few alarms. And then he started complaining about the salary he was going to pay me, because I had come through a placement agency, and he had to pay them, I think, 25% of my first year's salary. Okay, so if he hired me at $40K, he had to pay this agency $10K for the service of having introduced me to him. And he didn't want to do that, so he said, how about if I pay you, half what you'd be getting for the first 6 months. After 6 months, my obligation with them is ended, then I'll raise your salary and I'll give you a bonus to make up for the difference. Okay? lots of alarms going off now. And on the way out the door, he leaned over and he adjusted my tie for me. And then he got this serious tone in his voice, and he said, and by the way, a piece of advice, next time you go to an interview, lose the earring. He gave me this little fatherly pat on the shoulder. Okay. So I ran away from there. I'm like, there's no way I want to be involved with this person. Because I had just seen some things that made me wonder, like, where is this person's interests? You know. Anyway, a few years later, I heard on the news that he was being investigated for corruption charges for some of his contracting practices. So if it looks like a duck and it walks like a duck and it quacks like a duck, sometimes it's a duck. So sometimes you can avoid these kinds of situations up front. And it's hard if you're interviewing for a job and it's a really good sounding job and there's lots of money, but something's not quite right. You know, you may have to make a difficult decision then, but it may be easier than making it down the road when you're more involved. Sometimes it's not so cut and dry. So suppose you want to get a job developing surveillance systems. Okay, you're going to take footage from cameras and you're going to analyze the way people walk. You're going to look at their gait and figure out who they are without seeing their face, just by how they move, how their body goes up and down, and so on. Is it ethical to take your skill and your training and work on something like that? Well, it obviously depends what the system is going to be used for, right? If it's being used by something like the U.S. government, who presumably is following these ethical behaviors that you believe in, I won't dispute that one way or another. But if you have faith that it's being used in a way that is in harmony with your ethical followings, then that's probably a perfectly fine thing to be doing. But if it's a contracting company that you've never heard of, who doesn't seem to have a phone in the U.S., and doesn't want you to ask any questions, and doesn't care if you have a security clearance or not, you might want to wonder, like, where is this going to be used? Okay, who is this going to be used on? And am I comfortable with that? Okay. Yeah.
How important is security clearance in engineering?
It really depends where you are. So out here, probably not so important. If you were on the East Coast, like in the Virginia, D.C. area, really important. Most of the jobs there seem to do better with security clearance. You have a lot more opportunities.
I'm asking because I have a security clearance.
Okay.
Increase my pay, or?
Yeah, it can definitely increase your pay if for no other reason, because it's expensive to clear someone. And so if someone needs a clearance, you already have one, it can actually help with that. But there's lots of different kinds of clearances. There's lots of different agencies that do the clearance. If you got your clearance through DISCO and somebody else wants it done through another agency, then it may not be such an advantage, but it at least shows that you're clearable. So that can be a big help too. Bioweapons. Even if it's a government that you believe in, are you comfortable building a bioweapon? Is that something that you think is appropriate or not? Okay, rhetorical question. What if you're not actually going to be building a bioweapon, but you're going to be building a system that can be used as part of a bioweapon? Right? Are you allowed to say, well, it's not my fault that they're using it for that? Maybe you are, maybe you're not. Okay, it's an ethical choice, and it's largely a personal choice. The Trinity Project, these people were building the first atomic bomb, and they knew what they were going to do with their work. They were going to kill a lot of people. Okay, but presumably they were going to save a lot of lives. And most of us don't like to do that kind of math, to say, you know, these people will die and these people will live. But you can find yourself in that situation, and particularly as an engineer, because, like I said yesterday, that's what we do. I mean, we deal with large consequences. One that comes up fairly often these days is things like browser exploits. So you're a computer scientist, you're working in your lab, you find a way to get through a security hole in Internet Explorer. And using this, you can create a web page. If somebody surfs to that page, now you can get in and you can take over their operating system. Okay, it's pretty well agreed that you don't want to go and just like post that on your blog the day you discover it. Okay, so typically you would contact the person who's in charge of the software and you would say, here's an exploit I found, here's an example of how it is, and here's some ideas on how to fix it. What happens 6 weeks later when they haven't returned your emails and they haven't made any noticeable action in correcting this?
It's what Black House for.
Yeah.
Definitely.
Mm-hmm. So something that happens typically is the person will go public with it at some point, along with a fix. And I mean, you can read about this every few months, and a lot of times they get in trouble for it because you shouldn't have posted this on the web. But on the other hand, if they found it, somebody else will find it, and it needs to be fixed. So, I mean, these things are not always cut and dry, but a good starting point is to go back to that code of ethics and look through the canons and think about it from that perspective, think about it from the perspective of stakeholders, and if it's a real quandary, if you can't find one way or another, find someone to talk it over with, and go from there. All right, that's it for ethics for now. Friday we will talk about patents and IP, and this afternoon I'll be in the lab.
Friday. Probably won't finish it. So,
Guy in purple. I just remember that happened Friday, so,
most likely we're just going to brainstorm the Friday. Like, there's so many more to do. And you'll hear that. We're going to be here a couple times, so.
yeah. Just have to go. I for 8-5 is I dropped the class.
So you can't use.
You know all magic numbers?
What about
Engineering.
Okay. I'm meeting with Al, I'll do with that for you.
All right.
Here?
Yeah.
Might step up.
No, you can leave them in the box. I'll go ahead and give you your name.
Going in there right now. After this. Did you? Did you read through it?
Yeah, we
Actually, do you have a minute?
But did they take it?
So long.
Okay.
Homework reviews with these like my job for a long time.
cool. We had a nice explanation about average speed and so we have to do it's like 8 questions. But yeah,
That's what we do.
yeah, we finished all of them, but I wasn't completely comfortable with all the concepts, so
No, I took it to mean that
I got about 2/3 of
you
it.
said we'll do this work.
That's that one conceptual homework one.
Typically, like, people do it for $40,000. You pay $50,000 to get it.
It's on me.
So you work on contract legally, but more of that.
How much was the book for?
Other people have to do it. If you can see different ways out of it, I would say go ahead and say if this is what's happening, and this is
I was gonna get rid of it now, I mean.
I kept mine, I think, I don't remember why I kept it, I don't think, or I think I took it before you did.
There's like a, I have this version, we just start.
Oh, I just put it over there. No, we just put it up from there.